is under my name. Don't ask me why I didn't put the stickers, but I just decided it might be better to use my name. So if anybody gets there early, just ask for the 20-person group under mine. All right, so with no further ado, yes, Dale. Yes, Dale, hi.
Which champs is that?
That's the Champs on Canal Road.
Oh, Valley View.
Right in Valley View by the movie theater. Does everybody know where the movie theater is here?
Yeah, by the
well, we can caravan some people if you want to follow, and we can do what we usually do, and everybody just
go
parades
north
along
through that
the
road
road.
that
So it will be fine. You'll be fine.
turn right
All right.
take it out.
Without further ado,
That's more straightforward. Yeah, that's what I need.
All right. Well, I decided to do a segment. I'm calling it, Do You Think You're Sitting Still? Okay? I'm sure you all think you're sitting stationary and you're just sitting still. Well, the truth is, you are in motion in so many different ways, it's mind-boggling. I brought the worst props in the world, okay? But for now, this represents the Earth, okay? So, you know, we're at approximately 42 degrees north latitude. We'd be somewhere up here, and of course the Earth spins on its own axis in what we measure to be 24 hours.
No, it doesn't. It's flat.
Right, all right, forget it.
It's only 6,000 years old.
Yeah.
On a stack of turtles.
Right.
Anyway, so we're up here at about 42 degrees north latitude. So when the Earth turns, you can picture the spot where we are at makes a circle about like that. And I don't know the exact name of a section of a sphere like that. Yeah, but it's not a circle, it would be a chord, I guess. But anyway, all right, yeah, something like that. Anyway, we are actually moving along with the rotation of the Earth at a speed of about 770 miles an hour. Okay, so that's pretty fast, and it's faster than the speed of sound. It's not outrageous. So right now, we are actually traveling along with the rotation at about 770 miles an hour. But of course, the Earth, another great prop here, and I'm going to use it this way, the Earth is revolving around our star, the Sun, once per, as we measure it, a year, 365 days, okay? Now, that circle, I should have these this way, well, the big figures I cannot keep in my head, so I'm going to refer to them.
Miles radius?
Well, you got, the distance from the Earth to the Sun averages about 93 million miles, of course. Okay, that's just the radius, the distance from the Earth to the Sun. The Sun travels in a much larger circle, of course, so you go your 2r times pi, and that happens to equal 584 million miles. That is how much we travel in 1 year. Okay, and what speed are we going? Well, the calculations are relatively simple. I was going to put up slides for the numbers, but they're pretty simple. It turns out to be, well, if you take the 186, I'm sorry, the diameter, 186 million miles times pi equals a circumference of the orbit of 584 million miles. Okay, when you divide that by 365, that means we move 1.6 million miles per day. All right, divided by 24 once again, and per hour, it comes to 66,705 miles an hour. Okay, so that's pretty fast. All right, divide by 60 again, we've got 1,111 miles a minute. So that's how fast we're going around the sun. And that is fast enough that if we divide it by 60 once again and get seconds, it's about 18.5 miles a second. So not only are we spinning the spot where we're sitting right now, we're moving along with the rotation of the Earth at 770 miles an hour. We are orbiting the Sun at a pretty quick rate of 18 miles a second. Not only that, okay, like most stars, the Sun isn't stationary in space. It's moving in both a semi-random way and an organized way, okay? And you may have to help me. Do you know anything about, the stars are just whizzing along on their own. Usually it's gravitational interaction with other stars. What do you call that semi-random motion? This I didn't get the exact term.
Wobble? That would be a...
No, it's actually moving. It's whizzing through space.
That would be a standard high school.
That's close enough. Okay, all right. But anyway,
Well, they're going around the center of mass.
okay, now that's the organized way, but there's a disorganized way. Our sun, you can add another about 12 miles per second by our sun between you, all right? It's just kind of whizzing along with respect to our neighboring stars, and that happens to be how it's measured. Because when you measure motion, there's always a frame of reference, all right? So for the rotation of the Earth, it's the center of the Earth, okay? For the revolution around the Earth, we're using the sun as stationary to measure the velocity around the sun. Does that sound kosher? Sure. Okay. So, it's a little harder because the sun, along with its neighboring stars, are whizzing around in sometimes different directions. Sometimes they're semi-gravitationally bound, and they're heading in basically the same direction, but they're both in motion. So the frame of reference that astronomers use for this type of motion is they averaged out the motions of all the stars in our stellar neighborhood. In other words, our neighboring stars. So they measured that with respect to their average velocities, and we come up with another 12 miles per second that we are whizzing along with our sun. Okay, and it happens to be towards, I believe, okay, I wrote it down here. Generally in the direction of the bright star Vega, which is, or Vega is proper, right? Vega? Okay, pardon me. I forgot, I was going to say of contact fame, okay, that's where Ellie Arroway went for, what was it, 18 hours or whatever. But it's generally in that direction, and well, overhead tonight, as soon as it gets dark, it is Vega. So we're heading in that general direction. Why exactly? I'm sure, we could break it down and the gravitational interaction and this and that. Not only that, our Earth, along with our sun, is, let's pretend this is a galaxy now, okay? Look at it that way. And that way, it's going to, as Tim showed you, M101 in the Big Dipper, okay? Our galaxy is a spiral galaxy, very similar to that. Now the size scale is immense here. Our own galaxy is 100,000 light years across. Is that correct? It's just immense. We're talking. Our sun would be a mere speck. If our galaxy could be viewed from above, we'd see it as more like a pinwheel. Our sun would basically be almost undetectable. Correct? Because it's a fainter star. Our sun is a yellow dwarf star. It's not a real small star. So the scale here is getting immense. So our sun is approximately 2/3 of the way out from the galactic center, which would be the core of the Milky Way galaxy. And that measurement is an astounding, all right. If the Milky Way is 100,000 miles, or 100,000 light years across, we are at an approximate distance of 27,000 light years from the galactic center. Okay, once again, let's start doing some math. All right. We are revolving around the center of the galaxy. Well, of course, gravitationally bound with our own sun. It's carrying us and everything else. And it doesn't matter how you look at it. You can look at the whole galaxy is spinning, or you can look at that we are orbiting the galaxy, all right? So we're 27,000 light years from the center. Make that a circle, okay? That's a 54,000 light year diameter circle that the sun makes around the Milky Way galaxy, okay? And that translates to 10 to the 17th power, approximately, miles. That's a lot of miles. All right, well, let's apply the proper calculations. We come to an astonishing figure of 485,000 miles an hour. That is how fast we are moving around the center of the Milky Way galaxy. It takes 225 million years for a complete revolution. And interestingly enough, since the sun and Earth were born, we've made it around the galaxy 20 times approximately. So, that is about 485,000 miles per hour. That translates to 13 miles, or no, I'm sorry, 135 miles per second. So far we have a lot of motion, right? All right, 770 miles an hour, about 18.5 miles per second, another 12 miles per second. The sun's just moving through space, and we've got about 400 or 135 miles per second moving along with our sun around the center of the galaxy. All right.
So why aren't we busy?
Yeah, I don't know. We're not quite done yet. Yeah. All right. It gets a bit trickier when you start measuring the worst one of all, which is our entire Milky Way galaxy whizzing through space. Okay. All right. As it turns out, the cosmic background radiation, which is essentially the echo of the Big Bang, okay? It's a radiation at a certain frequency that is detectable everywhere. Anywhere we point, anywhere we look in the entire known universe is this radiation at this certain frequency. Turns out, and this is just crazy, I'm still not sure of the mechanics of how they found this out, but they did. We actually detect a Doppler effect, okay? Just like a sound when a siren's passing you and the frequency goes down. Just like Edwin Hubble and crew found out almost 90 years ago that things moving away from us in space, the spectrum will be shifted towards the red. And they call it the red shift, okay? And that's part of, that's the big reason why we know today that our universe is expanding. Well, we can detect a Doppler shift in the cosmic background radiation. This is how we know that our galaxy is whizzing through space, and we can calculate pretty accurately the velocity it's moving. All right. It turns out that all of us here in this room are whizzing along with our galaxy, the Milky Way, at a speed of 1.3 million miles an hour. That's the equivalent of 361 miles per second.
That's a beautiful picture, Ray.
Now, to get a handle on this, that's Cleveland to Los Angeles in less than 7 seconds. So that's pretty fast. So that is us going along with our entire galaxy, all right? Where are we going? Where is it going, okay? Well, you know, we appear to be heading at this 361 miles per second, the general directions of the constellations Leo and Virgo. That happens to be the direction of the Great Attractor, which Tim mentioned earlier on. You know, the Great Attractor is thought to be a huge conglomerate of mass, okay? And they estimate it's about 200 million light years away, pretty far. Now, even that's coming into question. There's been discovered in the same direction, even further beyond the Great Attractor, a huge conglomerate of galaxies called the Shapley Supercluster. And there's you know, a great deal more mass there. They're, you know, believed to at this point be way more mass. So this is pulling us, you know, our local cluster of galaxies and other clusters of galaxies in a general direction, okay? So it seems to go against the idea that the entire universe is just expanding in one direction. There's all kinds of other motion. Worse yet, okay, there's been a development in the last 3 years or so that there's a few tantalizing pieces of evidence for something they're calling the dark flow, okay? Of course. And it's yet another explanation. Why is so much of the matter in the universe seem to be moving in this one direction? They think now that there's a possibility that the dark flow is a pull from outside our known universe. Okay? It's kind of just speculation, but there's a few little tantalizing pieces of evidence. If you Google,
It's sucked into a black
okay,
hole.
and at this point, better leave it to astrophysicists to start explaining how maybe it's a big Jesus head or something. I don't know. But anyway, so in summation, we're not sitting still. We're whizzing around all over the place. If we were to total all that up in the different directions, I don't know what. Anyway, on to the space oddities. I decided to start sort of close to home here. Well, first off, we have Earth, which is pretty odd if you think about it. There's people here that believe some guy like rose from the dead, which is alien. Okay, that's pretty odd in itself. The Earth is pretty weird. All right, I'm going to start with, oops. Okay. All right. This is one of Jupiter's 4 largest moons, okay? And it's one of the ones that's easily visible with a backyard telescope. You can detect the moons of Jupiter with binoculars, okay? If you hold them steady enough, they're on a tripod. It's the moon Io, which it happened to be named after one of the servants of the goddess Hera that Zeus came down and made Jupiter with, okay? So that's what it's named after. All right, the interesting thing about Io, first off, is it looks like a rotten piece of fruit or a bad pizza like you might get at some fair or something. Okay? Why does it look like that? Oh, first off, well, it's the fourth largest moon in the entire solar system. And I believe it's somewhat smaller than our own moon, but not much. It looks like that because it's incredibly volcanically active. Now, it's not volcanoes like we think of here on Earth. It's spewing out sulfur dioxide and all kinds of stuff. I take that back. It is slightly larger than Earth, by mistake. Okay, now it's composed for the most part of silica rock and iron. It's not all that different in composition, I guess, from our moon. But yeah, it's strangely enough, it's a lot closer. Although it's one of the moons of Jupiter, it's a lot closer in composition to the inner planets. Mars and Earth and whatnot. Okay, and the interesting thing is, okay, as I said, it's the most volcanically active body in the entire solar system. There's about 400 active volcanoes on Io. And a picture of it in a somewhat different wavelength of light. And I would believe that most of those dark areas happen to be the volcanically active areas. Here's a picture of one down to the lower left. There is a active volcano, and you can clearly see the lava flows. That's an artist's rendition of what it may look like on the surface of Io, and they did a pretty good job. You can see that Jupiter is an enormous planet. So for Io, Jupiter is going to loom pretty large in the sky, so you can see the surface of Jupiter sort of off to the left. I thought that was kind of a nice representation. And that's another picture where you can actually see, okay, right off here is actually some of the stuff being ejected off into space. So that's kind of an odd body. Now, you couldn't see any of this detail with an amateur telescope. However, like I said, you could easily see Io itself. Okay, on to one of Saturn's moons. I believe it's Enceladus. I'm never sure about the exact pronunciation of this name. I'm just going to say Enceladus, okay? Anyway, all right. It's Saturn. Saturn has, when I was growing up, when I was a kid, I should say, they said Jupiter had 12 moons, Saturn had, what, 9 or something? Now it's way beyond Jupiter. Jupiter has 60-some, Saturn has tons and dozens. Yeah, dozens and dozens. Well, Enceladus is the 6th largest moon of Saturn. Okay, it's not all that huge. It's about 1/7 the size of our own moon. It's about 315 miles in diameter. Not too gigantic. All right, and for all practical purposes, it really doesn't look all that different than a lot of the other moons of the outer solar system. There's a lot of icy moons, except it is whiter. So what makes Enceladus so interesting? Well, it's a frigid moon. The surface temperature, because it's so reflective, is actually colder than the rest of Saturn's satellites. It hovers at around -300 Fahrenheit. That's a cold moon, okay? That's not what's odd about it. Enceladus happens to have geysers that eject water into space, okay? Regular old H2O water. This said, it was suspected for a long time. The Cassini mission really solidified and observed these things. And, as a matter of fact, Cassini, I think, passed within some ridiculously close distance to the surface of Enceladus. It was like 10 miles or something. So what might geysers of liquid water indicate? Well, for one, possibly. That's just it. For one thing,
Plant life.
it would indicate the presence of liquid water underneath the crust, okay? They pretty much know there are pockets of liquid water, but, quite possibly oceans. And for that reason, Enceladus has been the #1 target, let's say, for the possibility of life somewhere else, other than Earth in our own solar system. It was previously believed that Jupiter's moon Europa was the same thing. We know there's an ocean of liquid water. That looks like a cue ball, but compressed is smooth. But now they pretty much know that the ice crust would be too thick to really, support any kind, the possibility of supporting any kind of life would be very slim. Not only that, what causes of the surface temperature is so incredibly cold? Why would liquid water be beneath the surface? Well, there's a couple different reasons. Its proximity to Saturn, it orbits actually technically within the ring system, but it's in the outermost zone, which is known as the E zone. So its closeness to the planet itself is going to cause, I'm not a physicist, but it's sort of like a tidal heating or something, it's going to be having to do with the gravitational effects. But also, and this is very interesting, it's also caused by its imperfect orbit. And it's not a real elliptical orbit, but it just variates a little bit, caused by resonance with another moon of Saturn, okay? And it's locked into this kind of orbit. And we can really get off in a side trick about orbital resonance. Doesn't it sound like something wooey or something? Orbital resonance, but it's scientific fact, okay? There's sort of interaction between, it's partially gravitational, but when several bodies are orbiting at a certain rate, all right, an orbital resonance occurs when two or more orbiting bodies exert a periodic gravitational influence on each other, usually due to their orbital periods being related by a ratio of two small integers. All right, the physics behind orbital resonance is similar in concept to pushing a child on a swing, where the orbit and the swing both have a natural frequency, and the other body doing the pushing will act in periodic repetition to have a cumulative effect on the motion. And because of that, the orbit of Enceladus has this variation, and they believe that this could in turn cause some of its internal heating. Do you have a question, Dan?
Would that orbital resonance, though, tend to push the object farther out give it a larger orbit?
I think it all depends exactly where things end up, you know, when all the planets were forming, when each individual planet coalesced, and then, you know, its satellites, you know, however they were formed. Laura?
This has gotten me very interested more so than I have before. Are you guys aware of the planetarium at the Bay Village, Huntington Beach area?
No, but the one at the Natural History Museum is fantastic now. It's been right now.
Well, I was just thinking it's much less expensive at the Bay Village Planetarium at the Huntington Beach Park. Because I'm sure that one is really expensive, is it not?
Except they don't have any new programs there.
At Bay? Oh, I'm sorry. Okay, thank you.
All right.
They might have, but
How did you find that out?
Because one of the guys in the club was director there, he's now teaching astronomy at Cleveland State, but they're de-emphasizing the planetarium up there.
That's unfortunate. Thank you very much.
so that's the most exciting thing. Oh, Maud?
Yeah, I have a, this is kind of off topic, but looking at all this, I'm wondering, does anybody know why it is that the planets and moons, you know, the stars, the sun, the way we're seeing them, they're also elegantly spherical. Now, if your average moon is just a hunk of rock.
They're not. A lot of the smaller moons are hunks of rock. Look at Mars' two moons are tiny, and they're just like little blade thingies. They're just,
Okay.
yeah. They're not all spherical.
Like, but why are so many of the ones that we're seeing so very spherical? Is it
Yes.
Yeah, it just tends to be, it's one of those things where, okay, a philosopher might ask why. And what really is just, yeah, the gravity and the mass of the object, they tend to form. Why do galaxies form in, a lot of galaxies, not all of them, spiral galaxies like our own, form into like a pancake pinwheel? It's just the way, you know, the gravity and mass.
Keep in mind when most of these form, they're very hot because they're being formed from massive collisions, and they're literally molten. They begin to spin. As they spin, the gravity, the mass, the iron and the heavier elements go towards the center. Everything else comes in from there, and as it spins, it tends to take a kind of a spherical shape, but it's never perfect. Earth is not a perfect sphere; it's elliptical. But that's how it gets there.
Okay, thanks.
So this is a photo, it was from the Cassini mission of these geysers, these liquid, well, not technically liquid, it's water vapor. And some of it falls back to Enceladus as snow, and that's why it's so white. But this is a photo of the geysers injecting water vapor into space. It turns out that this, you know, pretty small moon ejects 440 pounds of water vapor into space every second. Not only that, one of the neatest things, and there's so much water is coming from this moon, it's formed a gigantic torus, or donut, if you want, if you will, of water vapor that it's like 373 million miles in diameter, or 1,000 miles. So much water that it actually deposits some on the surface. Well, again, the surface of Saturn is a gaseous surface, but still, it deposits water vapor onto the surface of Saturn and onto the rings of Saturn. So, that's Enceladus. And the most interesting thing of all, though, is that it is the candidate for life. Right now, it is the main candidate for existing life. Now, Mars, who knows, like, I'm hoping Curiosity finds a fossil. That would be the best. You know what I mean? That would be great. But for life existing now, this is, believe it or not, the prime candidate. Yes?
When the water ejects, does it freeze?
Some of it does. It freezes back as snow or ice crystals and falls back. And I imagine it would, you know what, in you know, let's say interstellar space, that's not proper. But after being spewed out into space, yes, I'm sure it does. The spot deposited as ice crystals. And there was one, let's see. All right, and there's what I thought was kind of a neat artist representation of it at one point.
That's a representation?
Yeah, no, that's very
Plain dealer son of guy up there.
Yeah, like, that's an awesome picture.
Okay, and that's yet another one from Cassini, I believe, that's showing the water jets. So it's an interesting little moon. And this is, Tim and I are trying to present a lot in 2 some hours. You know, we can give you the whole unit, but once I started getting into the oddities, I mean, there's like so many. I could go on with the solar system, but I won't. Now, I have a couple outside the solar system. Now, some of them go out somewhat into deep space. Like, where should I stop? It's not going to take all that long, but now Tim's going to kind
Maybe
of...
about 10 minutes.
Okay, but you're bringing it back. If I go out beyond, you know...
I go out pretty.
Okay, but I don't want you to have to come... You know what, it all ties together. Rather than switch back again, I think I'm just going to go through what I have here. All right, what's the nearest star to Earth, okay? Anybody know? Alpha Centauri, that's correct. Okay, what's interesting about Alpha Centauri is, you know, it's not, you know, we live in a single star system. Unless, you know, all the stuff about Nibiru or whatever is true, and there's a dark star or whatever, I don't know. The interesting thing about Alpha Centauri is the multiple system, okay? Alpha Centauri A and Alpha Centauri B are what you call binary stars. They orbit each other around a common center of gravity. It turns out the two aren't that far apart. It's an elliptical orbit. The closest they get is approximately the Saturn to Sun distance. The farthest they get is approximately the Pluto to Sun distance. So there's 2 stars, okay, and Alpha Centauri A is very sun-like, very, very sun-like. Just about the same spectral class. Is it exact, you know? It's close. The G-class star, very similar. It's about 1.5 times as luminous as our sun. So if someone were to take our sun away and put Alpha Centauri A in its place, like the oceans would evaporate like real soon and everything. But basically it's the same spectral class. Alpha Centauri B is still, if it was a standalone star, would still be considered the type of star that could harbor planets that may harbor life. It's a K-class star. It's about 90% the size of our own sun, but it's cooler. It's like more like an orange star, class K. So those 2 stars are a binary system, okay? But now planets, it would be kind of tough with 2. Picture in our own solar system, we got another star that got as close as the planet Saturn, okay? Another entire star, sun. It may be kind of tough. At this point, now I didn't really research into it. I don't think they've really found anything. Planet-wise, I don't think. You know what I mean? Planets for planetary bodies in the Alpha Centauri system.
Not yet. We have about 2,000 kilometers direction.
Yeah. But nothing in this particular system. I think because of the dynamics of the system, it's
Kepler
just...
may not even be looking in that direction. It's looking at a wedge. About 225,000 stars in the general neighborhood, but it may not even be looking in that particular direction.
Which is ironically the closest star, but the dynamics of this, that would be kind of rough, it would seem, for a life-bearing planet to evolve. It's possible, I'm sure. Alpha Centauri has a 3rd component. It's Proxima Centauri, or they call it Alpha Centauri C. Okay, now this actually... You know what? I don't know if I actually put that down here. You can see how much smaller it is now. It's a much smaller, much cooler star, a red dwarf star, class M. And they're not even sure at this point if it's actually gravitationally bound to the other 2. Some data suggests that it is, and it has a rotational period about the other 2 of several 100,000 years. There's other data that suggests that, it actually lies about a trillion miles from the other 2 stars. And technically it is closer to us than the other 2, because of its location in space, and then it's so far from the other 2. Proxima is the closest star to Earth besides the Sun. Well, there's other data that suggest that it's kind of like a renegade star that's just sort of on a hyperbolic trajectory, and it's going to end up leaving the star system in a couple million years. So that's what's interesting about Alpha Centauri. Okay, and that's, I'm not sure if that's a Hubble image or not. I forgot to jot it down. But that's Alpha Centauri A and B. Okay, moving on to our next oddity. We have what is called Eta Carinae, okay? It has the designation of Eta, which is the, now I always forget if that's going to be the fifth letter of the Greek alphabet, or it's a little different. Alpha, beta, gamma, delta, epsilon. Okay, Eta is somewhere. I don't know where Eta is either. Okay. Well, it turns out Eta Carinae. Okay, Carina is a southern constellation. We can't see this object from here. I'm not sure offhand. Maybe from the southernmost United States we can see this. So Eta Carinae is it's basically one of the most luminous, massive stars known. Okay, it's considered to be about 150 times the mass of our own sun. It's now known that it's actually a binary system, very similar to Alpha Centauri. What's really interesting about this star system, actually, and its associated nebula, obviously, it doesn't look like a star, does it? Well, at one time, they thought it did consist of about 150 solar masses, which is pretty big. It's thought to be around 120 at this point in time because of what is evident in this picture. It's obviously blowing off something, all right? So, in the year 1843, the nebula surrounding, we call it the homunculus nebula. It's part of the larger Eta Carinae nebula system. But the homunculus, I can barely say it, nebula, actually surrounds the stars or stars itself. So, by the way, we were talking about this on our Manliness forum a couple of years ago, and people immediately said it looked like something obscene or whatever. We dubbed it Crom's scrotum. Or something like Crom was the god of Conan. Anyway, all right. So, obviously something's going on with this thing, all right? All right, in the year 1843, it brightened enormously, and they thought it was a supernova at the time, people that were doing their astronomical observations. It turned out it faded back after a few years, so it was almost what they call a false supernova. The thing is, with a star this massive and luminous, it uses up its fuel very quickly. Basically, the most interesting thing about this space oddity is, it could, at any time really, it could be any time between right this moment or several million years from now. It may not only go supernova, if the star is massive and luminous enough, they would call it a hypernova, okay? Now, it's 7,500 light years from Earth. And the crazy thing is it could have already blown up, all right? Because it's 7,500 light, we wouldn't know about it for 7,500 years, right? So it could have already blown up. Whether it's in the process of blowing up right now in this picture, it looks like the lobes are pointed sort of 45 degrees away from us. Luckily, not that it could cause, huge damage. However, the star is so massive, there was so much incredible energy there that even at 7,500 light years distance, it could shower us with gamma rays. If the explosion was in the general direction of Earth. Now, it's fun to think, like, oh man, we'll get fried or whatever. But no. At most they would think maybe it would be a reaction similar to the solar flares that our own sun is,
There's some kind of a nova that produces, I think they call it a gamma ray laser, where it first comes out on each pole.
That's frightening. Yeah.
If it heads towards us.
If there was a nearby supernova that did
Nothing has
that,
to be that
Halfway
close.
across,
oh, that's far. I
It
would
is.
pinpoint it.
It
Wow.
goes far.
I once joked on the mailing list about that alien, you know, they thought the star Gliese or Gliese 581 was habitable or whatever, and about how the alien civilization was just getting our, or no, I'm sorry, in the year 2029, they were starting to get transmissions of like Glenn Beck and Sarah Palin. And they were a real developed civilization. But they started to see this stuff and they were like got worried and they concentrated a laser, gamma ray beam and fired it, which would arrive. The star is about 20 light years away, so it would arrive about 20 years later and we'd be toast. Wow, yeah, I'm going to look more into that. Yeah, that's frightening.
Might be worth
and because it's like a laser, it doesn't dissipate.
Okay, yeah, so like, even like that situation, you know, it may just dissipate out into more like a laser. Laser, oh boy, that's scary. So that's kind of a neat object. I think I have one. Yeah, that's a little more.
Did that light help you more?
Yeah, it's fine. I could barely read my notes, but that's all right because the images look better. So that's in a slightly different light. The image is the same thing. Same thing. So that's kind of a neat object. So if it did blow, oh, and this is a larger part of the Antipathetic Carina Nebula. So the star and its little homunculus nebula is somewhere embedded into that area there. It's a spectacular area, but yeah, we can't observe it from here, unfortunately. There's a lot of neat stuff in the southern sky that we just can't see here. In fact, the two brightest satellite galaxies of our own galaxy, the Magellanic clouds, are pretty neat, probably even in binoculars, but we can't see them. Okay, I think I just have one or two before I'm going to turn it back to Tim. This is, you know what, I'm going to do the other one first because it's a simpler version of the same object. Okay, this is what is known as NGC, and Dale was asking about other designations for sky objects. This one doesn't have a Messier designation, but it's NGC is the New Galactic Catalog, and they started cataloging in the NGC quite a long time ago, wasn't it 1800s or something? It was long. It was, yeah, it's been quite a while. So I think it only goes up to 9999 though, to start going to something else. So this is known as the Helix Nebula, NGC 7293. It is a planetary nebula, which essentially is, you know, there's a star right there in the center, okay? It's basically a dying star. It blew off a bunch of its outer layers, okay? Now, ironically, when the Hubble photos of this object started coming in, the religious seized on it. The eye of God! The eye of God! But, you know, it's kind of funny about the dying star. It's not exactly everlasting life, is it? You know? But it is a spectacular object, Laura.
Off the subject, back to the darkening of the Earth moving. This is a frightening thought, but maybe we're being pulled into a black hole.
Nothing has been detected, you know. That'd be kind of a neat thing. You never know. No. We know one's at the center of our own galaxy, so who knows? You know, that could grow and then the whole galaxy could explode. Okay.
It'll all happen December 12th.
Yeah, exactly. So this is a planetary nebula, nothing to do with a planet. It's just the way when they're first observed, a lot of them show a disk. So, and the telescopes weren't powerful enough to see the central area and the central stars. So this thing, you know, it's pretty big. I mean, this, I believe it's, you know, when it blows off its outer layers, it gets large. I believe this thing is it's 700 light years away, not all that far. The diameter of it, I believe, is it's something like, it's pretty large. It's several thousand light years. So, anyway, that's the Helix Nebula. And this can be observed on a very, very dark night with a small telescope. It has very low surface brightness, they call it. So you want a low power lens for this thing. It actually takes up a larger area in the sky than a lot of these deep sky objects. So you want a low power lens, the constellation Aquarius. For us, it's rather low to the horizon, but I've seen it. I've seen it in a small telescope. You get a better view from somewhere, south of here, like South Florida or something like that. This is in the fall sky, in the evening of the fall sky. So that's the Helix Nebula. Now, believe it or not, oh, and I think I had a few extra photos. That's a little more distant photo. It looks even more like an eye. There's even like an eyebrow above it.
Are these the actual colors?
The colors are often exaggerated to show detail.
Yeah.
I think the first one for this particular nebula, the oranginess was a little more accurate for this object. Okay, well, I'm going to wait on that one. Wait a minute, what happened? Oh, I know what happened. Okay, there we go. This is, believe it or not, the same type of object. It's a planetary nebula. This is known as the Cat's Eye Nebula. All right, I mean, it looks like a rotifer or something. I mean, it's a weird looking
It's like a cigarette smoke.
cigarette. Okay.
How people can blow
Right.
circles?
Well, that's just it. It's got multiple rings and stages, and that's really a mysterious thing. I mean, we know what it is. It happens that this one was a kind of not a real huge star, not a real massive star, but a super bright star is at the center of this thing. And it appears to be blowing off its layers and sort of stages, which accounts for, it's got kind of like a rippled structure, Very, very odd looking object. And they're thinking that it started losing its outer envelope, so to speak, about 1,000 years ago. So, this hasn't looked like this forever. Matter of fact, the little mascot nebula that's on our meetup page, okay, that's essentially the same kind of object. That has shown incredible change over the last just 20 years. I forgot the exact name of the object. We've had it on our meetup page for forever. The one in the corner, and it's actually a JPEG, animated JPEG. So, about 1,000 years ago, this star started blowing off its outer layers. And this is about 3,000 light years from Earth. So once again, not real far. And, the most interesting thing about that, they have no idea why it appears to be blowing off in stages like intervals like that. The mechanism this time is just not known. Okay, and I thought I'd say something about the picture that I put on this meetup. Oh, here's another interesting thing, okay, that the religious kind of seized on.
That's God's hand.
Yeah. This was just discovered recently, and it was like, oh, it's a hand.
Mark,
So, yeah.
remember at the park when we all looked up at 10 o'clock at night and saw the space station?
Space station, yeah.
How often would we be able to see that?
It's visible quite often, actually, yeah. But not always ideal for people at a certain spot on Earth. That happened to be perfect for us. It passed over and it lasted a long time.
Yeah.
So anyway, if you guys see the hand is, let's see, it would be sort of like that over there. So yeah, they right away the religious latched onto that one.
Pass the football to Tim Tebow.
Good one. Yeah, the hand of God, and now it's called the hand of God. In reality,
Is it really?
Yep.
Oh,
It looks like a hand.
Yeah, they found out it really. No, this is what you call a reflection nebula. It's a pretty distant one. That's why it wasn't discovered before. It's upward-ish. It's fairly distant, but it's a reflection nebula. Generally, okay, some of what they call the Orion Nebula. Would you call that a reflection nebula? But that's really a birthplace of stuff.
It's a birthplace, but it is a reflection.
Yeah. So some of these are actually birthplaces of stars. This one I'm not technically sure about. The hand-like structure could just be gas, a bunch of dust and gas that's illuminated by stars in its vicinity. So that's the hand of God. Okay, no, we don't want that one. No, we don't want that either. I went out over it. Okay, my last oddity object is the object that I put was featured on the meetup page for this meeting. Tim mentioned this earlier on. It's in a pair with the galaxy M81. This is M82. Okay, it's sometimes called the cigar galaxy. When they started looking at this thing with Hubble and whatnot, well, actually the jet things were seen long ago, the ground-based telescopes. This was known for a long time as the exploding galaxy because they actually thought the thing was blowing up. Now, actually with Hubble, we see it in far greater detail. That's not any kind of foreground gas. The red is actually part of this object. And this is an entire galaxy, like our own Milky Way galaxy. This type of galaxy is called a starburst galaxy, okay? It's 5 times more luminous than our galaxy. The intensity of the energy that it puts out. It's called a starburst galaxy. Okay. And in this particular galaxy, at this galaxy center where all this activity appears to be emanating from, stars are born at a rate of about 10 times faster than are born in our own galaxy. So it's just basically a hyperactive type of galaxy. And as Tim might mention a bit later on, just recently there was this discovery of a galaxy cluster that was making something like 750 times the rate, making
740 stars a year.
Oh, okay.
And Milky Way makes about 2.
About 2, so yeah, like this is a cluster, and that was the brightest galaxy in that cluster. So this newly discovered galaxy is even more hyperactive than this one. And since it's so active, all kind of emissions come from it, like X-rays are more intense and that sort of thing. But perhaps most interesting of all, in April 2010, radio astronomers working at Jodrell Bank, University of Manchester, found an unknown object in M82. That's one of those annoying rings. Okay. Okay. Yeah, the radio astronomers at Jodrell Bank Observatory at the University of Manchester reported an unknown object in this M82 galaxy. The object has started sending out radio waves, and the emission doesn't look like anything seen anywhere else in the universe before. They have several theories about this, but nothing really fits the data. Okay. They think it could be some kind of micro quasar thing, a new type of object that we don't really know about. It just, it emits very high, frequency radio waves and low X-ray luminosity. They honestly don't know. It's located at not quite the very center of this thing, but a little bit out from the center. So, and it has what it's called is, now I don't quite understand this, it's superliminal motion that it's compared to the, I don't know how to wrap my head